Hey guys, my name is Trevor Sullivan and welcome back to my video channel. In this particular video, I wanted to go over a pretty simple concept that's incredibly useful, but you might not know about if you're new to the Rust programming language. What we're going to be talking about in this video is one of the core traits that's built into the standard crate as part of Rust. If you drill into the documentation for the standard crate here and take a look at the different modules that are provided by the standard crate, you'll find this really simple one called default here. And all it does is expose a trait known as default. Now, if we drill into the default trait right here and take a look at the implementations for it, you'll actually see that there are standard implementations for default across many of the primitive data types in Rust. So if we have integers or unsigned integers, floating point values, even boxes surrounding certain types, errors, file times, string values, and all sorts of stuff, there's lots of default values that are set up when you construct a particular type. Now, the only function that is provided by default is a function called default that takes no arguments, but it returns an instance of the type that it's implemented for. Now, you can just do a basic implementation on your custom data structures in Rust by using the derive keyword in order to, it's actually an attribute, but you can use the derive capability to specify that you want to derive default for all of the values in your data structure. And this simplifies constructing new instances of your custom struct because you don't have to specify all of the field values that you want to initialize a new instance of your struct with. Now, you can also apply default values to custom data structures that you've defined. So even though we can't necessarily define a default value for any of the primitive data types, because we can't implement a default or we can't implement a trait for a type that's not declared in our own crate. So in order for us to implement default for a type that's already declared in the standard crate here, we can actually create custom data structures that simply wrap the primitive data types. Also, there's a really cool mechanism that allows you to do partial constructions of your custom data structures. So if we want to use default values for certain fields, we can just call the default function as an input to the field value. But if we want to specify certain values, say on a child struct here, then we can specify and hardcode those values, but then we can use the dot dot operator to indicate that we want to use default values for the remainder of all of the fields defined on that child structure or parent structure for that matter. So we're going to take a quick look at how this works, but before we jump into the code, please remember to head out to my YouTube channel at youtube.com/Trevor Sullivan. Subscribe to the channel as I am an independent content creator and your support goes towards helping me produce more videos. Also, leave a like on this video if you learned something new about the default trait, and also just leave a comment below and let me know what you thought of this videos and any other Rust topics that you want to see videos on in the future. So in any case, we're going to switch over to our integrated development environment, which is VS Code right here. I've already created an empty project directory here. So if I just do ls-lga, you can see I've got nothing in here. So what we're going to do is just do a cargo init, and that'll go ahead and initialize a new project here. And then we are going to go ahead and just modify our main.rs file here. And we're not going to create any separate modules. We're just going to keep things really simple here. And for starters, what we're going to do is just define a custom data structure. So we'll do something like person, which I use in some of my other examples. And we'll just say that a person has a first name. So we'll do first underscore name, and we'll set that to a heap allocated string. And we'll do the same thing for the last name. And then we'll do an age of, how about unsigned 8-bit integer. And I think that should be good for now. Well, maybe we could also do something like location and just set that to a string value as well. All right, so normally if we want to construct an instance of a person, we'd have to come down to our main function here. That's our entry point to our application. And then we would do person. And then we can specify the curly braces here, and we can specify any input arguments that we want to pass in to the person. So we could do first name is Trevor dot to string. We could do, last name, etc. But every time that we construct one of these instances, we have to provide some kind of initial value for these inputs, right? We have to specify all of the fields here. Otherwise, if we're missing any fields, then we're going to get a complaint from the Rust analyzer here saying that we have an incomplete initialization. So it says missing age, missing location, because we've only defined the values for the first name and the last name fields. So one way that you could kind of solve for this is to simply implement a constructor function and say, all right, I'm going to create a function here called new person, and this will return an instance of person. And in this case, we could just say return a person, and we could set a bunch of initial values. So we could take these values right here that we've already defined, and let's just go ahead and put these on new lines here to make it a little bit more readable. And so then we'll fill out the age, and we'll set that to, how about 26? And then we'll set a location to United States dot to string. All right, so you could do this, and then you could just call that function and say, all right, I want a new person. So I'll say let p1 equals new person. So that works perfectly fine. However, the issue here is that this is a non-standard convention. There's no kind of standardization as far as what you call this function. So we called it new person here. We could also implement a function at the person struct level and call it new. You'll sometimes see that convention used in certain types in Rust as well. But another way that we could initialize a person more simply is to provide an implementation of default values. So for now, let's just go ahead and comment out this new person function. We're not going to use that for now because that doesn't follow any standard conventions. And instead, what we're going to do is simply use the derive attribute here to say that we want to derive the default values for each of these fields. So as soon as we derive default here, that's going to expose a default function on our type here. So we can just do person default, and that'll automatically give us a person struct instance with all of the fields predefined to their initial values. Now, the values that are determined for each of these fields is going to be determined by the data type of the field itself. So if we take a look at the default value for a string, it's probably going to be an empty string, right? So if we say default string, and then plug in a string default value here, then we're probably going to see that that is empty. So let's comment out person default there, and we'll just do cargo run. And as you can see, sure enough, default string is just empty, right? It's still a string. It just doesn't have any contents inside of it. So this is useful because it does allow us to construct a person with relative ease here. As you can see, that compiles and runs just fine. But if we want to initialize our custom data structures with values that are different from the defaults, then we can do a custom implementation of the default trait and actually determine what that default function is going to return. So let's go ahead and instead of doing the derive right here, we will comment that out because we don't want to do the default derivation. But instead, what we're going to do is create an implementation block for the default trait for the person type, which is our custom data structure. Now, if we hit Control Space right here, you'll see that it automatically generates the method signature because this is being implemented for a given trait here, right? So it knows that the default trait declares a default function with no input arguments, and it's going to return the type of whatever self is. In this case, it refers to person, but whatever type it is that you're implementing default for, that is what the capital S self refers to here. So right inside of this standard default function here, we can simply instantiate a person in a standardized fashion and build on top of the core traits that are provided by the Rust standard crate. So what we'll do inside of here is literally just return everything that we have right here. So let's take all this code from that new person function, and we'll paste it in here. So now every single new person that gets created is going to default to these values instead of having an empty string for first name, an empty string for last name, number 0 for age of 26, because that's an unsigned 8-bit integer, and a location of United States instead of, again, an empty string value, right? And then if we need to, we can customize any of those values whenever we construct a person. So now, instead of deriving default, we have actually given our own custom implementation of the default trait. So we can still use this function call right here. And we'll just say let p1 equal person. And of course, Rust infers that this p1 variable is of type person because the default function here for the default trait always returns whatever the self type is for that implementation. So what we could do is just say person default, and that'll give us a person with some default values. Also, I'm going to derive debug up here just as a little helper so we can print out the debug output for it. So then in print line here, we'll do a pretty print template, and we'll say default person is, and then we'll just pass in whatever p1 is. And if we do a cargo run, you can see that our default person is a person struct instance with a first name, last name, age, and location all set to those static values. Or you could even select from randomized values and just plug in kind of a random name there. And it's really up to you how you want to implement this default function to provide a default value. Now, if we wanted to construct a person, but only provide certain inputs, we don't have to any longer provide all of the input fields like we did by default. Normally, we just saw earlier how we'd have to define first name, we have to define last name, we have to define age, and so on and so forth. But when we have the default implementation here, we can actually specify that we want to use the default arguments for any missing fields that we haven't defined. So let's say that maybe I wanted to change the first name field here to Shannon. And of course, we need to call toString because we need to change this string pointer into a heap allocated string. But then, just like the example that we saw in the documentation, we can go ahead and use ... default to indicate that we want to use all of the remaining arguments on this person type. Now, in this particular case, you're going to see that it can't find the function default in the current scope, and that's because we haven't specified that we want to use the default trait from the default module. So at the top of our main.rs file, we'll do use standard, and then default module, and then finally, we want to use the default trait from that module. And as soon as we provide that, we should be able to resolve the default function. So let's see what's going on here. Now, I almost forgot that this is actually a nightly only experimental API, so hopefully in a future version of Rust, we'll be able to utilize this feature here. But since I'm running a production build of Rust, I can't currently use this syntax that's indicated in the documentation down here. But that's perfectly fine. We can continue learning about this trait. So one of the cool things that we can do with our custom data structure here is to actually wrap one of these core data types with our own custom data type instead. So what do I mean by that? Well, let's say that for first name, we want to have a string have a default value, but maybe for last name as a string, we don't necessarily care about having a default value, and maybe the same thing for location. Well, we can't specify a default value for the string because this trait, the trait default, is not declared in our library. It's defined in this standard crate, and the string type is also part of standard as well. It's not a type that's defined in our crate. So if we were to try to say impl default for string, and then we specify function default here, we get this message that says only traits defined in the current crate can be implemented for this type, essentially. So basically what this means is that because the default trait is defined in standard and because the string type is also defined in standard, we can't, in our separate crate, our application, we can't actually implement this trait for this custom type, or this, I should say, this core type. So what we can do instead to solve for this is to actually create a data structure called first name, and wrap the string type inside of that. So now we have a custom structure here that has its own separate type, but it's based upon the string type here. So now that we have a custom data structure here, we'll actually be able to go ahead and use this in order to implement the default method. And because this data structure is not wrapping any other fields, we actually don't use the curly braces. We just put a semicolon on the end, and that's how we declare this struct wrapping the string type. So now we have this custom struct called first name, and because first name is declared inside of our crate, we have the control to be able to implement the default trait for this custom type. So what we'll do down here is say impl default for the first name wrapping a string. And now what we can do is specify the default function here, and we can return a custom string value for our custom type here. And I think it doesn't like the fact that I have the string in there, so we're just going to return first name. And now we're getting this message because our function isn't yet returning an instance of our first name. So all we need to do is construct the first name object and initialize the default value, and then return that back as the value for default. So let's say that I wanted my name to be the default for any first name for a person that we construct. So I'll just say return first name, and then we'll wrap our string value in here and just say Trevor.toString, put a semicolon on the end, and now we are satisfying the return value, which is self, which is the data type that we are implementing the default trait for. So that's all we have to do to implement a custom string value for this type. But then we actually need to go to our person type down here, and we need to change the data type of the first name field from string to the first name as well. And that will allow us to assign a first name wrapping a string as the value for the first name. Now you're going to see this message that says first name doesn't implement debug, so we'll go ahead and implement that here by using derive debug, and that should allow us to print out the value. So now when we return a new person, we can simply initialize the default value for the first name field. So we'll just do first name and then just call default here. And then if we ever want to change the implementation of default here to maybe randomize the first name or select from a certain list of first names that we provide, maybe an avec type here, we can go ahead and change this implementation of the default method and make minimal changes to the rest of our application here. So we can use this technique of wrapping the primitive data types in Rust with our own custom data type, and then we have the ability to control which traits are implemented for our custom type, because Rust simply doesn't allow us to implement traits on types that our crates don't own. So now when we construct a person, right down here, we'll go ahead and do a person as default values. And whenever we construct a person with default values, the person is going to have a first name field which contains a value of the first name custom data structure wrapping the name Trevor. So if we wanted to, we could just go up to the implementation of the default value and change it to something like Shannon. So now whenever we construct a person with default values, we always have Shannon. So it's up to you how you want to implement a default value here. There's a lot of different options you could do to kind of randomize data if you need to kind of generate some fake data for testing out an application or testing out a database schema or something like that. But even though this default trait is really, really simple and straightforward, it does provide a standardized mechanism for constructing new instances and assigning some default values to them. So I really like this trait. It's simple to implement, but it provides a very nice standard interface. So this is going to be a pretty short video, but I just wanted to kind of show you what the default trait looks like. I hope you learned something new, and we'll see you in the next video. Take care.